Welcome to Lesson 3 of our Chemistry from Zero to Hero series. Today we're becoming matter detectives and learning to distinguish between physical and chemical changes. When you tear paper, melt ice, or burn wood, are these changes the same? How can you tell if a new substance is formed? In physical changes, matter changes form but not identity, the molecules stay the same. In chemical changes, matter transforms into completely new substances with different properties. Let's uncover the secrets of matter transformation. Let's explore physical changes where matter changes form but not identity. In physical changes, the substance maintains its chemical identity, only physical properties like shape, size, or state change. The molecules themselves remain unchanged. Think of it like rearranging furniture in a room. Examples include state changes like melting ice or boiling water, size and shape changes like cutting paper or crushing cans, mixing and dissolving like sugar in water, and other changes like magnetizing iron or crystallization. Most physical changes are reversible, which makes them very useful in food preparation, manufacturing, construction, art, and recycling. Now let's examine chemical changes where new substances are formed. In chemical changes, substances transform into completely new materials with different properties. Chemical bonds break and form, creating new molecular structures. Think of it like baking a cake. You start with flour, eggs, and sugar, but end up with something entirely different that you can't easily unbake. Examples include burning wood, rusting iron, cooking food, digestion, photosynthesis, and battery operation. Chemical changes are usually irreversible, involve significant energy changes, create new substances with different properties, and are fundamental to life, technology, and our world. How can you tell if a change is physical or chemical? Look for these clues and evidence. For chemical changes, watch for color changes like fruit ripening or silver tarnishing, gas production like bubbles from baking soda and vinegar, temperature changes without external heating or cooling, and precipitate formation where solids form in liquids. Use our decision flowchart. Ask if a new substance is formed with different properties, if the change is difficult to reverse, and if there's evidence like color change, gas, precipitate, or temperature change. If yes to most questions, it's a chemical change. If no, it's likely physical. Remember some tricky cases like dissolving being physical and color mixing being physical unless new substances form. Let's explore real-world examples of changes in daily life. In the kitchen, cutting vegetables is physical while baking cakes is chemical. Melting butter is physical but toasting bread is chemical. Around the house, burning candles and rusting nails are chemical changes, while breaking glass and evaporating water are physical. In industry and environment, shaping metals is physical but making plastics is chemical. Decomposition is chemical while the water cycle is physical. Our bodies undergo both types constantly. Chewing food is physical while digestion and respiration are chemical. Life depends on the perfect balance of both physical and chemical changes. Just as we have physical and chemical changes, we also have physical and chemical properties that describe matter. Physical properties are observed without changing the substance's identity and can be measured directly. They include extensive properties like mass and volume that depend on amount, and intensive properties like density and melting point that don't depend on amount. Chemical properties describe how a substance behaves during chemical changes and include reactivity like flammability and reaction with acids, and stability like corrosion and oxidation. Scientists use these properties like detectives use clues to identify substances and predict their behavior. The best way to understand changes is to investigate them yourself. Try these safe experiments. Observe ice melting for a physical change. Mix baking soda and vinegar for a chemical change with gas production. Dissolve salt in water for a physical change. Watch steel wool rust over days for a chemical change. And with adult supervision, observe candle burning. Practice scientific observation skills by noting properties before changes, looking for evidence during changes, and comparing results after changes. Always remember safety first. Adult supervision, safety glasses, no tasting, small amounts, good ventilation, and proper cleanup. Good observations lead to accurate conclusions. Congratulations on mastering physical and chemical changes. We've learned that physical changes alter form but not identity, are usually reversible, and don't create new substances. Chemical changes create new substances with different properties, are usually irreversible, and show evidence like color change, gas production, or temperature change. We've explored properties of matter and how to identify changes using evidence and the "Can I Get It Back" test. In our next lesson, we'll explore elements, compounds, and mixtures, the classification of matter into pure substances and mixtures. Keep observing changes around you and stay curious about the amazing science in everyday life. Thank you for learning with Silent Reader Chemistry.